let's delete this window. And we go back to our schematic. And we press Q to open the property box. Now, what we need to do, the amplitude, we don't need to change the amplitude, we just need to put the amplitude to be 1 volt, so we can easily observe the amplitude output relative to the amplitude of the input, as we have explained earlier. But for the frequency, it will be a variable instead of a fixed value. So let's say I say frequency in. Okay, that's the name of my variable, and we press OK, and then I go to the master file. First I need to save and check. Go to the master file. When everything is ready, I go to the variable, the global variable, and then I click add variable, and then I can add the variable name, which is our frequency in. I want to have 3 cases, so one is 100 Hertz, right? And then we semicolon. One is at the -3 dB frequency, which is 1 kilohertz, and then we semicolon again, and the other one is 1, I think it was 10, yes, 10 kilohertz, and we press OK. Okay, it doesn't accept the scientific, so we can just normally do it like this. Or maybe it's not semicolon. Let's just comma. Okay, cool. That's syntax error. Now we can save it, and we can go to our for the analysis. We don't have to change anything. We just need to go to the results, and now we can run the simulation. Now you can see 3 cases are run at the same time. We can wait and see if the running has not finished. For example, you have something pending, and 3 cases are not finished at all. We can fix that error by going to, I think run, maybe. Oh no, we go here and we go to setup. Oh, not this one. Option. We go to option, and we go to top setup, and we need to choose ICRP. We need to choose ICRP when we run the parametrization. Otherwise, in some cases, all of the cases will be not finished. It will be in the running mode, in the pending mode, as if you had seen earlier. Now we have all of the 3 cases. We can choose the new sub window, and we plot the signal. One signal. For the first case, we delete this one, and we choose this sub window, and we go back to our master file. We plot the second one, but we will choose append, and we plot it. We delete it. Now you can see they are the same as we did earlier, and we can change the color to blue. Yeah, right. Okay, now let's plot the second case, where we have the frequency at input frequency at 1 kilohertz. We right click and we choose which sub window am I in? Okay, I'm in the transient sub window, so it's good. Go back here, we choose append, yes, and we plot. You can see that now the V in when it's 1 kilohertz is the same case here. Now we can go to be smaller. Now you can compare those two. You can see there's the difference in the frequency. Yeah, because the frequency here is faster. So of course you will see more period. That one. And then we will plot the output of the 1 kHz input sine wave, and we plot it. Now this is the V out. The other one, we can choose another color like maybe orange. Yeah, and you can see only seeing those two cases. We can disable the other two signal, which in the first case, and we only interested in the second case. And this is what we observed when we have the input signal 1 volt amplitude and the frequency is at the -3 dB frequency, which is 100. Well, sorry, which is 1 kilohertz. This one we don't like it, so we can delete them. And now let's plot the third case. We can choose both of the signal at the same time and you plot it. Now you can see even smaller now. This is the V in for the third case. We can choose the color. Maybe red. Yeah. You can see. This is how it looks like for the third case when we demonstrated earlier. And that's the parametrization will help you. That's how parametrization is useful for if you want to plot a lot of cases and compare between them very fast. You don't want to do one by one. You can do all of them in one simulation running. And now we can measure the bandwidth. The one way to measure the bandwidth or the bandwidth or the -3 dB frequency point is to go to the transfer function here, and we use the vertical marker, and then we move it where we can see the amplitude of the transfer function is decreased by -3 dB or decreased by 3 dB, and the phase is decreased by roughly 45 degree. Then at that frequency is the -3 dB frequency. But however, we can use a expression from the calculator, and then we can measure that point automatically. We go to Tool, and we choose Calculator. First we can delete this one, and we choose VF, and we choose the signal V out. And we go to Fn, which is the function panel. We choose special function here, and we choose bandwidth, and the signal is the Fn. VF means the output voltage in frequency domain, and of course only the output voltage in the frequency domain. We can see that. And for the type, we will have 3 types: low, high, and band. This is my guess, but maybe low means we predict that the characteristic is the low pass. If you want to know exactly what does it mean, we can go to help here. There's a help window, and Cadence will guide you to the documents of the function, the meaning of each parameters that specified in the function. But now I think that's enough. We press OK, and the function will be applied on our signal, and we can plot it here. And of course the bandwidth is only a value. It doesn't change. You know, even if you have the input frequency sinusoidal around 100 Hz, or the input sinusoidal at 1 kHz or at 10 kHz, the transfer characteristic of the system stays the same. It means the bandwidth or the -3 dB frequency of the system doesn't change when we change the input. That's why for all the frequency of the cases, our bandwidth is always one value at 1.0 something kilohertz. Now we can import that expression to our simulation. We can go to the calculator here and we press this symbol. To check, we go back to our Maestro file and we go to the output setup. You can see the expression is imported into here. Now if we run the simulation, we go to the results, you can see the expression is evaluated for each case. And we can wait for all of the 3 cases running. We can start to see the result be here. Now you don't even have to measure the bandwidth or the -3 dB frequency by hand. You can use expression in the calculator and import the expression into the simulation. And you can see the result immediately right in front of the results. And I think that's the end of the video. Thank you so much for watching, and I hope that is helpful. If you find that it's helpful, please give me a like or subscribe, and see you in another video. Goodbye.